Sungai Kim di Pasir Gudang, Johor tercemar.
Kini seramai 2,775 orang dirawat di beberapa hospital di Johor.
Sebuah sekolah di sekitar Pasir Gudang diarah tutup sehingga
Percayai berpunca daripada sisa bahan kimia dari Sungai Kim yang tidak diurus dengan baik.
Assalamualaikum and good evening. Welcome to today's special environmental report.
Today, we revisit one of Malaysia's more serious environmental incidents, the Sungai Kim pollution crisis in Pasir Gudang, Johor.
The incident shocked the nation and raised serious concerns about environmental safety and public health.
But what exactly happened, and why is this case still being studied today?
Let's take a closer look.
Assalamualaikum and hello everyone. Today we will be reporting on one of the most serious environmental pollution incidents in Malaysia, the Sungai Kim pollution crisis in Pasir Gudang, Johor. This case gained national attention after the illegal disposal of chemical waste into the river triggered the release of hazardous toxic fumes, affecting thousands of people living and studying nearby. Located in the heavily industrialized area of Pasir Gudang, Sungai Kim is surrounded by numerous factory and chemical processing activities. In 2019, what initially appeared to be an isolated pollution issue quickly has developed into a major environmental and public health emergency. The incident quickly escalated and raised serious concerns regarding environmental safety, industrial waste management, and public health. Although the incident happened in 2019, studies and reports published between 2020 and 2025 continue to examine its causes, long-term impacts, and important lessons that may help prevent similar disasters in the future. This incident reminds us that water pollution is not only an environmental issue, it can also disrupt communities and create serious social and economic consequences. For this reason, solving environmental pollution requires a comprehensive approach, one that combines engineering solutions, stronger regulation, responsible industrial practice, and ecosystem restoration to better protect both people and the environment. In the next section, we will examine the causes of the Sungai Kim pollution incident and explore its environmental, health, social, and economic impacts. That's all from me. Now return to the studio. Thank you.
Thank you, Putri, for the great explanation of the Sungai Kim incident.
Now, to better understand what actually caused this pollution crisis and how it affected the surrounding community, we go to our reporter Azwa, who is currently at Sungai Kim Pasir Gudang.
Azwa, over to you.
Thank you to the team in studio. Now I'm currently here at Sungai Kim, where investigation detected a highly toxic mix of chemical in the air, including ercoline, methymercaptane, and benzene, among others. What made these gases especially dangerous was that they are heavier than normal air.
For example, methymercaptane is almost twice as heavy as the air we breathe. Because of this, the gases naturally sink and remain close to the ground.
At first, many believed that bad smell come only from waste dumped into the river. However, later investigation revealed something unexpected. Data show that
some toxic gases were likely released from high factory chimney before being carried by the wind toward nearby building and acting even the upper floor.
These gases spared the community soon faced a serious health crisis. Victims experienced vomiting, dizziness, sore throat, and breathing difficulties. Sadly, school children become the main victim, especially those studying on the third and fourth floor of their school. Children are naturally more vulnerable because harmful chemicals can be absorbed faster and in large amounts compared to adults. Beyond health impact, the diseases also disrupted daily life. Schools across Pasir Gudang were temporarily closed, while clinic and hospital become overwhelmed with patients. The situation worsened because nearby rivers were already heavily polluted. Reports show that Sungai Kim was classified as a Class 3 polluted river, while Sungai Masai was classified as Class 4, making them more vulnerable to further contamination. This tragedy clearly shows that industry development without proper safety control can put entire community at risk. So, what can be done to prevent this from happening again? To answer this question, I will now pass to Alif, who will explain our proposed engineering and AI-based solution. Thank you.
Thank you so much, Azwa. To solve this issue, we propose Pillar 1, which are engineering innovation. First, we suggest upgrading the physical infrastructure by adopting the Pasir Gudang Storm Water Master Plan, including the installing of gross pollutant traps, or GPTs, at major industrial drainage outlets. As shown on the slide, this system acts as barriers that trap heavy waste and oily chemical pollutants before they enter the main river. However, engineering alone is not enough. To strengthen this system, we also integrate artificial intelligence, or AI technology. Instead of relying on manual sampling, IoT sensor nodes would be installed along rivers and factory chimneys to monitor chemical level in real time. Whenever unusual chemical activity is detected, the data is sent to a central AI database. By analyzing wind speed and direction, the AI can perform backward trajectory modeling similar to the scientific method shown in figure of our reference report. Within seconds, the system can analyze the pollution pathway and identify the most probable pollution source, helping authorities narrow down the responsible industrial area for faster enforcement action. Overall, this transforms environmental monitoring into a faster and more efficient system. Next, I will pass to Ain, who will explain how policy improvements and natural treatment approaches can further strengthen these proposed solutions. Thank you.
Thank you, Alif. Now, I will discuss on the policy and natural treatment solution proposed to address the issue. For our policy solution, we recommend improving zoning guidelines to better protect nearby communities. According to the ASM report, the previous industrial buffer zone was only 500 meters. We propose expanding this safety zone to between 1 and 1.5 kilometers, especially near residential area and schools. We also suggest strengthening the Environmental Quality Act 1974 by introducing clear legal safety limits for toxic gases such as acrolein. In addition, all industrial chemicals should be registered in the JKKP CIMS database to reduce untracked waste disposal and improve monitoring. For the natural treatment approach, we propose constructing engineered wetlands and sediment basins along industrial drainage systems. Following recommendations from the Pasir Gudang Stormwater Master Plan shown in figure here. This system acts like natural filters, which helps to trap pollutants before they spread further downstream. We also recommend using phytoremediation by planting native vegetation along riverbanks to naturally absorb toxic chemicals. Together, this solution helps strengthen long-term environmental resilience and improve community safety. However, an important question remains: how practical, effective, and sustainable are these proposed solutions? To answer this, we will now turn to Aliana to evaluate the feasibility of these proposed solutions and explain how they support the United Nations Sustainable Development Goals, or SDGs. Thank you.
Thank you, Ain. After evaluating all-purpose solution, each approach offers different strengths and limitations. In terms of effectiveness, the engineering solution using gross pollutant traps and AI monitoring system is highly effective in detecting pollutant early and preventing contaminations from spreading. However, in terms of feasibility and cost, this system requires high investment, technical expertise, and regular maintenance. Meanwhile, policy and regulatory solutions are more cost efficient in the long term, but their success depends on strict enforcement and industry cooperation. The natural treatment approach, including wetland and phytoremediations, help restore river ecosystem naturally at a lower operating cost, although it may take a longer to show the result. From a sustainability perspective, our integrated proposal balance environmental, social, and economic needs by reducing pollutions, improving community safety, and lowering future environmental costs. Most importantly, this proposal strongly support SDG 11, sustainable cities and communities through stable living environments, and SDG 12, which is responsible consumption and production by encouraging responsible waste and chemical management. In conclusion, solving the Sungai Kim crisis required not one solution, but an integrated approach combining engineering, policy, and ecosystem restorations. Thank you.